the classroom as well. So let me refer to this one because it has been newly produced last year and more update detail. But the previous set of PowerPoint or slides is also fine. Actually, most of the contents are kind of the same. But anyway, what I'm going to explain now, the share screen. Yes. No, it's screen. Is it there? Screen sharing successfully? Did you see it? The other friends could. Did the screen sharing? Yes. But how can you see the sharing? Okay, maybe you misunderstood this sharing stuff. I need to share the whole screen. Okay, let's see. Okay, how about this? All right. Then this one, we will talk about Protege a little bit. Then we will start doing the creating an ontology, and we will use a domain of pizza to be an example ontology to create. Okay, and do a few things. My target is that we should finish around 3:30, I think. Then that, otherwise it's too much for today, and then I will leave you to do some practice. Okay, so the plan is I go through this quickly. You don't need to follow step by step, but maybe once you understand the whole picture, then after this you can carry on and do the practice on your own machine. Okay, but understand the concepts and the things together first. Okay, first a little bit about Protege. Okay, it is a free and open source platform available on Windows, Linux, Mac, and so on. It has GUI user interface to help editing, creating ontologies, modifying, revising, changing, even doing some reasoning and a few other things. So actually, I did not introduce this from the beginning. We can even use it to create RDF schema, RDF description, Sparkle query as well. But I want you to do it from scratch and from the ground too before trying to use the tool. Otherwise, you will never look at the syntax. You would just use the click, click, click interface. Okay. All right. It can support several other syntax as well, and query, as I already mentioned. Sparkle is possible. DL will be description logic is also possible. Let me see on here. Okay. And then, no. How can I allow this? Okay, maybe I cannot make it full screen and enable the pen. All right. Plugin. Okay. Later on, please try to install plugin as well, because we may need this. I mean, the bare Protege may not be equipped with so many things, but Protege allows a lot of plugin development and installation. So this one, it's called Snap Sparkle Query. It allows us to do Sparkle Query with Protege and the ontology that we create. Okay. Follow all these things, okay, later on. Don't do it now. Okay, let me talk about Pizza Ontology. We will use Pizza as an example of creating an ontology. When we, okay, I need some example from here. Okay, I'm sorry that I switched back to this one. The thing is, why do we need an ontology for a pizza domain? let's assume that I want to create a pizza ontology for my pizza restaurant. And I want my pizza restaurant to be equipped with some kind of recommendation for my customers, such as you. The thing is sometimes customer and okay, before my restaurant, pizza restaurant has a lot of variety of pizza and maybe so many pizza, and our customers may have not known a lot of pizza or may have some queries, may want to ask about specific pizza to eat and for recommendation and so on. So what I would do is that I want customer to be able to ask questions related to the pizza that they want, such as some customer may want to say that I am vegetarian, but I have problem with spice. So please recommend vegetarian pizza with least spicy. Or maybe I have another customer, maybe a cheese lover, and who come and say, I love cheese. I want pizza that's full of cheese. Top with 4 types of cheese, 10 types of cheese, or something like that. Maybe I have another customer coming and ask, I am in favor of seafood. Any pizza with seafood? Okay. Or some may say that I want some pizza with this and that ingredient. Any kind of pizza that contains such specific ingredient. Or someone could say that I want to eat pizza with wine. What types of pizza that goes well with some wine that I like? Something like that, okay? So this is the thing that I want the ontology to be the kind of knowledge foundation that supports question answering recommendation of the menu to my customer. So actually, the very first thing for creating ontology, and it is very similar to developing a software, that is, you need to define the scope, because ontology is a domain conceptualization, right? So how big is your domain that you want to conceptualize? How small it is, or how deep it is, how broad it is? This is what you have to define. But how to define it? The easy way, I think this morning we have Potanan saying methodology approach, but in this approach, I will simply explain the similar thing, that first you need to determine the requirement and scope. The way to determine the requirement and scope is through what we call competency questions. What kind of questions your ontology should be able to answer? Give yourself some idea, okay? Maybe, of course, it can answer thousands of the questions in general, but you may need to give some direction, broad, specific questions, okay? Okay, such as, I may want my pizza ontology to be able to answer this kind of question, such as, what pizzas have both capers and anchovy but no meat? So this indicates that your pizza ontology should have knowledge of ingredients, right? That's it. You can change meat, caper, anchovy to cheese, to spice, to this and that, but it knows ingredients. So your ontology, now the scope, at least from this one, it tells that somehow ingredient need to be model. But if you want your pizza ontology to answer things about price, which pizza is cheaper than 200 baht, for example? Oh, okay, then you know that not only ingredients. Our customer care for price and cost, they have to pay. Something like that. Or which pizza has origination from, pizza must be Italian, right? But somehow, let's say kind of fusion pizza originated from Thailand idea of the menu, something. Then this gives you the scope of how your ontology should cover. Okay. Okay, so this is already what I said. It indicates in this example, indicates basic content and scope, indicates ability that it should be able to answer things related to toppings, or sometimes something like categorization. This is specific topping of the pizza, right? This is no meat. This is not specific, not about instance, but this is about categorization or class, that the class of topping should be nothing that is under the class meat, right? This is categorization. Okay. And these are some other example. Which pizza characteristics should I consider when choosing a pizza? Vegetarian, non-vegetarian, ice cream, vegetarian, okay, pizza base, and so on, the spicy. I think that's all from this that I should have said. Okay, so let's move to another one. So let's see and focus on this CQ, okay? For example, this is what we already consider, the pizza with some kind of toppings, such as mozzarella, tomato, but no meat. Or pizza from specific countries, as I already mentioned. Pizza that is kind of made for specific customers group. Thin or thick bread, that is kind of thin bread or thick bread. Types of cheese, even how about calorie? Yes, right? Maybe we're concerned about calorie. And even something like counting. Okay, I am kind of topping lover. Top me with so many toppings, okay? All right, and then finally, we may need to think that in this way, what and how do we define classes for our ontology? Remember, your ontology needs class, property, or relation, right? Axioms or rules. And instance. These are things you need for your ontology. Okay, the 4 components. On this screen, it has only the classes. First, the first thing to define in an ontology is to start from class. So in this case, we have something like, okay, let's start from food, a little bit upper level, because pizza is the type of food, a kind of food, okay? In our, everything is a thing. So the topmost class will be thing. So anything you create will be under thing. So let's see here, we create food, okay, as one class. Under food, we can consider the main class pizza. And of course, pizza could have the class, another related class that we can think of is pizza topping, as well as pizza base. Pizza base means the bread. When we create a pizza, You need a bread for the base, right? The thick bread, thin bread, and so on. You need to add toppings such as many cheeses, sausages, olive, what else, right? These are the toppings. And so bread and topping, both of them combined together become a pizza. So again, back when I commented on your RDF schema, don't come with anything such that, how can I delete everything? No. Don't do that. Pizza topping is a subclass of pizza. No. Why? Remember, everything is a subclass of something when it is itself is also an object of that class, right? Is pizza topping a pizza? Never. You cannot order a pizza and then you get pizza topping, right? Pizza topping is just the cheese, it's just the tomato, the olive, and so on. It's not pizza. Never model pizza topping as a class of pizza. They are related, fine, but they are not subclass, okay? The same for pizza base. If you order a pizza, you get from the shop just the bread. Is that what you want? No, right? So pizza base is also not a subclass of pizza. Don't do that. This example is fine, but when you are going to model things for yourself, for your mini project or something, okay, this is common mistake that I will need to warn this first, okay, but maybe we will see. We will see, but I may need to have a checklist before you make a presentation or submit any ontology to me of your design. Check the subclass that is real subclass or not. Okay, anyway, so look at this. If we talk about pizza base, okay, this is easy. There are two types of pizza base in this example: deep pan base and thin and crispy base. Okay, in my restaurant, this is my restaurant, so I want only two types of bread that you can choose. Then this is the base. But then my pizza will be classified further by having this thin and crispy pizza, meaning that it is made of that thin and crispy base, right? Then it becomes thin and crispy pizza. Then this is fine. Thin and crispy pizza is fine. It is a pizza with thin and crispy base and also with toppings, okay? It may have cheesy pizza as another subclass, and also we will define what does it mean by cheesy pizza. It means that by default, you need to assume, right, that it must have cheese. Otherwise, it's not cheesy. And it may have some other class defined here as name pizza. Name pizza means it's some name. For example, we have margarita. Have you heard of margarita pizza? What does it have? Cheese and tomato sauce, right? Just the tomato. Yes, that's it. No meat. Okay. It may have some other name pizza like American hot, and so on. Okay. Back to the pizza topping, then we can define many types of pizza topping, many subclasses, such as, remember, why do we need to do this? Because we need to answer something like, customer may want to say that I want pizza with cheese only, I want pizza with meat only, I want pizza with this and that. So you need to classify based on the topping, such as cheese topping, spicy topping, meat topping, vegetable topping, fruit topping, nut topping, and so on. Okay, these are the topping for pizza that I classify further, and it may have some further subclasses, such as for cheese topping. Further, I have mozzarella topping, maybe some other types of cheese too, but in this example, just simple one. Meat topping, I have chicken, hot spicy beef, maybe sausage, maybe this and that. Vegetable, we can define olive, mushroom, garlic topping. Okay, they all are topping. Things that are under topping must also be topping, right? There are subclasses and so on. Then next subclass here is something that we define as further things related to the taste of the pizza. Don't make the taste of pizza under pizza subclass, right? Taste is just taste, such as the taste in terms of spiciness. Then we define spiciness to be medium, mild, and hot. Okay. Okay. So remember, we need 4 things, right? As components, define classes, define properties. Oops. Okay, then define individuals or instances. Then we can add certain axioms. And we can run a reasoner to do some query and reasoning something. First, we will do the class. Every class must have a name, okay? And you can define the class hierarchy through subclass. And you can define that different subclasses, are they disjoint or not? For example, okay, this is first to create classes. From here, you could see we focus on just these 3 classes. In our ontology, we are not going to create very complete pizza ontology, but good enough, okay? We need 3 classes here: pizza topping, pizza, and pizza base. These are 3 classes. They are not subclasses of each other. They are both under food. They are all under food. But let's say I'm asking, are they disjoint? Do you know the concept of disjoint? What does it mean, disjoint? Again, please. Very good. A class, 2 classes are disjoint when members of both classes, when one member of one class is not a member of another class, right? No member of one class become a member of another class. So if you draw, I think we learn in very small time, the time when we are very small, Venn diagram. If this is class A and this is class B, every member of class A and every member of class B, they are not overlapping. These are disjoint, right? So are they disjoint? Could we have some pizza topping becoming a pizza? No. Could we have pizza base becoming a pizza? No. And pizza base and pizza topping, can we have disjoints? Do you want to have some bread to be topped on your pizza? Maybe not, right? Okay, consider that way, right? So they are all disjoint. Okay. All right. In our example, let's say that we are not going to have the food stuff. We start from pizza. Okay. Create 3 classes. Okay, you follow the interface later on. I think this is step by step and easy. I'm just explaining the idea of the ontology. We need these three classes, namely pizza topping, pizza base, pizza. In any order is fine. It will be sorted anywhere somehow later on. Don't worry. You can create through this interface. Even you can make the indentation to make the subclass. So if you want to say that under pizza there is cheese pizza, you can do like this using indentation, then it will be fine. And if you want everything to be disjoint, there will be interface for you to tick that make every class disjoint. Okay. And these joints are talking about siblings because they have to be in the same level. Sibling means they have the same parent, then they are siblings. Such as here, under thing, this is the parent. This class thing is parent. These three classes are direct children of thing, right? So they are siblings and they all are disjoint. If we talk about cheese pizza and pizza, are they disjoint? No, because if this is cheese pizza, how can I draw pizza? Bigger or smaller? Inside or outside? Outside, yes. So cheese pizza is inside pizza, right? So they are not disjoint. Disjoint only defined for sibling classes, okay, but not subclass. Okay, then let's, what you have to do is make things like this. Create the class hierarchy. But how can, of course, before you can create this, you need to have the modeling concept of the pizza in mind, right? You can, but of course, this is given. And in that case, we call domain expert. I mean, how can you make this model? You must, if you are not the domain expert, you must consult a domain expert, right? Domain expert will help you. You may need to talk to, interview, work with domain experts in order to understand this kind of conceptualization, what class, upper, lower, subclass, superclass, more general, and so on. So here you could see pizza topping. These are those many types, subtypes, okay, class, subclass, pizza base also. All right. And I think this is clear. We have the class pizza topping, the big circle. Inside pizza topping, we do have vegetable topping. Inside vegetable topping, you may have tomato topping, right? And this explain, I mean, this diagram tells you the subclass is smaller set inside the superclass, right? So everything that is a subclass will become automatically the superclass. And this way, if you try to draw, you will never miss concept, misconceptualization of creating class and superclass. Okay. Then that's all done. First for the class. Next is properties. There are two types of property. Remember, object property and data type property. Okay. Let's look at some further detail. Object property is used to relate two instances, two objects. Data type property is just an attribute of an instance having certain literal value. That's it. For example, if these two are instance, Matthew and Gemma, relationship is has sister. This is a property. This is an object property because it links or relates two instances. But this one, Matthew, is an instance. Has age is a property, but this has age has a value 25. So this is data type property because the value of this property is just literal. Okay? So you have two types of properties to be defined in Protege, whether it is object property or data type property. That's it. And this way you can later on define domain and range as we already learned before. So let's say that I have the property, the first one called has ingredient, in which the domain supposed to be pizza class. The range supposed to be some other class, which could be the topping, which could be the pizza base, because these are the ingredients, right? So I define this as a property, as ingredient, and for sure, because it relates objects of two classes or instances, it is for sure object property or data type property. Object property, right? And it has sub property, two sub properties in this, has topping and has base, meaning that has topping is a special kind of has ingredient, right? A special property, a specialized property. Has base is also kind of subtype of has ingredient. Okay. And you can define, create object properties and use indentation to make sub property too. Okay. And what else we can do? We can define inverse property. Inverse property means it's another direction, such as, remember my previous example? John and Mary. What example I use? Has a wife of and husband of. So these are inverse. Once you know wife of, you know husband of. It is inverse. So we can define inverse. In this example, has ingredient is a property. A pizza has ingredient something. Then that something is an ingredient of a pizza, right? It is an inverse. The same for has topping. This pizza has cheese as a topping, has mozzarella cheese. Mozzarella cheese is a topping of that pizza. The same, okay? Has base too. Same thing. Is base of is the inverse. So you can define, create new properties and define that they are inverse of each other. Okay, is base of is an inverse of has base. Is topping is an inverse of has topping, and so on. Just follow the GUI is simple. Just click, click, tick, tick, check, check. Okay. Okay, this is the example diagram illustrating that pizza class and oops, need to be careful of my touching. Okay, pizza class and pizza topping class are relates with has topping. Okay, so if this pizza has this topping, then it means this topping is topping of this pizza, right? That's just the direction. So you follow the direction here and direction that. Okay. And it allows what? When you define the instance value and relation, you define only one direction. Inferencing or reasoning mechanism will do the inverse for you. You don't need to explicitly define everything, right? You explain only one knowledge, one thing, you know. Then the other way around will be infer automatically by the reasoning engine. This way, you allow that people can ask questions several ways, but then still your knowledge engine can answer. Okay. So next is to define domain and range, and that is easy as well. You just click and say specify that for the hash topping property. Its domain is pizza, its range is pizza topping. And the same, similarly, hash base. What is the domain? Pizza, and the range? Pizza base, yes. Okay, and what else? Transitive. Transitive means let's look at an example. It's easier. Transitive means when A has relationship X with B and B has relationship X with C, then A will have the same relationship X with Z as well. That's the transitive relationship. For example, Matthew has Peter as ancestor Peter. Peter has ancestor William. Then Matthew also has ancestor William. This is transitive property. So if we define, for example, has ingredients with transitive property. So let's say that a pizza topping, if pizza A, okay, has ingredient. Remember, has ingredient is a super property of has topping and has base. Pizza A has ingredient something. Okay. And that something has ingredient. Oh, ingredient. Something else. Okay. It means pizza A also has the ingredient something else too, right? This way allows customer to query something with the chain, the transitive, because if you say that I am allergic to cheese because I have maybe lactose intolerant, okay, I cannot eat cheese. So it may not say that pizza A has the ingredient of that cheese, but something else that is used to cook pizza in the ingredient, something A has cheese somewhere. Then maybe we need to be able to reason and find that no cheese is found anywhere in every ingredient used, right? The same if we are strict, I am strict vegetarian, meat cannot be added into my pizza, but also if some other ingredient somehow has some meat based stuff, I cannot eat too, right? So I need to make sure that this transitive property works. So we need this has ingredient to be defined as transitive. And to do this, you can simply use the checkbox again that which property is transitive. Then when you do the query and reasoning, it will work for you. So we say that transitive has ingredient is transitive. And functional property. Example is here. When has base, a pizza, right? It is a pizza has base, which is pizza base. And we want to say that this has base is functional. It means that the kind of the cardinality of has base is just one. So, I mean, your pizza can have only one base. You cannot have double base, right? It's not a sandwich. Then you have only one base. So that is to define it as functional, okay? The range, the value, the object, the instance that is related through this property is only one instance. Similar to has spouse. I mean, in general, right? Has spouse seems should be a functional, right? We are allowed to have only one spouse, okay? Something like that. Okay. Next is creating data property. This is easy because it's just literal. So you can do the same. Similar way to create an object property, but it's just different tab or something, different tab. And such as here, we can define data type, which is called has calorific content value. I would just say has calorie to be easy word, but anyway, it's the same thing, okay? So we want this has calorific content value to have the range, which is integer. The domain, of course, is pizza, right? Pizza has this calorie, and the range must be integer value. Okay. Another type of properties you can create is called annotation. Good ontology should be human readable and also easy to maintain. And that means you need to have some annotations for humans to understand what it is. These are a set of annotation for your ontology, such as comment, label, and many other things, see also, and so on. So be sure to every time when creating an ontology, add the annotation properties to describe your own ontology and describe each of the class property you define. Okay, such as here, we add comment for this is annotation for the whole ontology. Okay, it's a description of your pizza ontology. So we can say that it is a pizza ontology that describes every pizza based on the toppings. But each specific class, property, and so on, you can also add the annotation to your class too. Okay, then this is the result of ontology annotation after you add it. We use RDFS comment. Remember when you go to DBpedia, most of the objects in DBpedia, when you list, they will have comment. Comment is one common way to annotate everything, okay, including ontology, instance, class properties. So once you have your ontology, you can define the ontology URI. Okay. You can define the comment and very many things. Okay. And as I already mentioned, we can create annotation for classes too, such as margarita pizza. We add comment saying that is a pizza that has only mozzarella and tomato toppings. This is definition or comment or annotation of margarita. Don't forget to define the data type so that it's kind of properly set. And okay. Next is that you can create individuals. Individuals now, you can create many things, okay, many individuals. First one is country, because we want to define that which the origination of certain pizza is from which country, for example. We can create type or class country and define the two instances such as America and Italy. Never define these two things as class, right? Italy is not a class, America is not a class, but it's a country instance, right? So this thing you should be able to understand when things are class, when things are instance. Okay. Now, suppose that everything is fine. We can do further for the okay, let me see. I think we still need some time, but shall we do like this? I'm tired. That's the thing. So I try to negotiate. So we stop here. Okay, this is what I'm going to negotiate now. We stop here on this slide number 20. We finish up to 28. Okay. We can continue next time, but I will continue explaining, but I want you to follow and go through everything until the end. Understand or not? Let's try. Okay. But next time I will explain everything from 29 onward too. But in terms of practice, yes, it's already in the classroom. It's in the class material, yes. So I just uploaded today. So follow everything until the end, okay? Try to understand by yourself, but next time I will explain. And then we go through some of the reasoning query stuff together. And I want you to start thinking as well. I try to add details into the classroom very soon. That is about the mini project. Because after practicing this pizza, understanding concepts of ontology through pizza, through a few things, and also through the presentations of several readings, case studies, it's now the time that you think of something and model it using ontology. That is the goal for mini project. So I would like to ask you to start thinking, brainstorming, finding what could be a topic for you to model ontology. So you can propose an ontology to model. All right, okay. So let's continue. We were here from last time we were up to creating some classes, creating some properties, in which there are two types of property, right? Remember that. Let me recap a little bit. There is, in terms of class, what we did is that you can create new classes, name them, right? You can define the classes that are in the same level to be disjoint. Okay, and of course, you can create a hierarchy having classes under the superclass and forming the structure of superclass, subclass, and so on. And this is what we call class hierarchy. You can then define properties in which there are object properties and data type properties. And both of them contain domains and ranges. Okay. So we could also define individuals or instances. In ontology, right, you can create an instance. So in this case, it could mean that you may have an instance of a pizza, an instance of some topping, cheese, bread, and so on. And the next step that I think we still need to continue and discuss in detail is about certain axioms in which you can define by our restrictions. And we will discuss 3 important types of restrictions, which is quantifier restrictions, hash value restrictions, and then cardinality restrictions. Okay. For these individuals, I think this is quite simple, right? If you have a class country, you can create an individual such as America, Italy, Thailand, India, Myanmar, and so on. Okay. So learn to distinguish again class versus instances or individuals. They are different. Okay. All right, then let's look at the axiom part. Before we go there in the detail, you need to make sure that your Protege works fine, right? I got some message from Paramik. You use 5.5, and actually version 5.5 is kind of pretty new, but did someone, has anyone used different versions? And okay, so everyone used 5.5 or what? 5.6.1. Okay, but what's wrong with Paramik when you try 5.6 or what? Five point 6.1 doesn't show classes and subclass. I think they do. But which environment you use Paramik? Mac OS, Windows, Ubuntu, or which operating system? Windows.
Yeah.
Okay. Anyone use 5.6 on Windows? 10, right? And it's fine. Yes, I think it's fine, Paramik. But anyway, if 5.5 works for you, then just keep it. Even I started using Protege when it was version 3, then version 4, 5, but I don't remember which version I installed. Maybe I did not update to the newest one anyway, but it still works fine. So don't worry, we don't use the very new features anyway. But I think new features are kind of bug fixed and also maybe performance improvement and so on. But core features that allow doing reasoning, querying, defining classes, defining properties, defining axioms, they all work fine in even starting from version 4 and so on. Okay, so anyway, any version that works well on your machine, that's not a problem. Okay, so let's start. Let's continue with the first type of axioms, which is called quantifier restriction. I think we learned this from the college level as well, undergrad level, in terms of logical condition using quantifier. I think this also based on set theory. Let me adjust this a little bit. Okay. Do you recall anything with this terminology? Existential quantifier or existential restriction, universal restrictions. These are related to, I think, the theory as well. Okay, anyone used to learn this? No? In mathematics, in logic class, have you learned this kind of symbol? Yes or no? Yes? How about no? No one seen this before? Let me know. No, don't worry. I will be teaching. So everyone has seen this, right? Okay. But your facial expression doesn't show me that you know this, but you didn't raise your hand too. So I'm confused as well. You call the symbol, but maybe don't remember the detail or what? Okay. Anyway, all right. For the let's look at it in an easy way from an example point of view. If we want to say that for existential, actually in the old day, we use the description saying that, oh, well, this doesn't. We say that, now even this doesn't work for me. Okay, let's try. Okay, we use the word some, right? For some and for all. That is what we learned when we were younger, okay? And what does it mean? It is used to express the relationship. For example, we want to say that a pizza must have at least one or actually some topping, right? To be a pizza. If you have only the bread, is it a pizza? No, you need a bread and you need at least some topping, right? Some means could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, fine, but cannot be 0, right? So that existential restriction here should mean that at least one, or for some, at least some, okay, having some. So this can be a class of things having at least one mozzarella topping. This is your mozzarella topping class. This could be instances of mozzarella topping, right? There could be many types of mozzarella topping instances. Then there's something, some object has this topping. Some object has this topping together with that topping. So something, not only pizza, right? But could be something else also has topping. When you eat ice cream, do you have topping? Yes, ice cream also has topping, right? Not only pizza that has topping. But anyway, we are focusing on only just the pizza. So we are saying we want to assert or we want to say a condition that a pizza is a class containing objects such that object in this class must have the has topping property for at least one. Okay, that's it. So the way to say this is has topping some pizza topping. So this is a property. You are making restriction to a property. And this is the property has topping. Okay, you are making restriction to the pizza class, but on the has topping property. That pizza class must have topping, which is some pizza topping. This is the range. So actually, if you consider If you consider has topping property, the domain is pizza. Okay, the range is pizza topping. So we are restricting that pizza must have at least one property has topping connecting to the pizza topping. Okay, let's look at how about, no, it doesn't work. What if I change? Okay. Wrong. Okay. Anyway, let's look at the universal restriction. Okay, let's see this one, which means only or all. It means that suppose, okay, let's look at the example. Vegetarian pizza has only vegetable toppings, right? You don't allow, if you're vegetarian, you don't allow any meat to be there. So it means that vegetarian pizza can only have vegetable toppings. Or in other words, this means for all, right? So it means that for all toppings of vegetarian pizza, they all must be vegetable toppings. That's it, okay? So the way to assert this is to say has topping property can only have only vegetable topping or a so-called vegetarian pizza. But if it is just any kind of pizza, it is fine, right? But if you are defining vegetarian pizza, you allow only vegetable toppings. Okay. Then, how do we do that? I hope you already did, right? Last time I asked you to practice and try. So the way to do this is by creating a new class, and then you can make an expression, okay, by making class expression and type in or use the user interface GUI to say that let's say this one, it is the pizza base restriction, right? But previous one, you can do the same using this class expression. You can create a vegetarian pizza or add details about pizza as well. Anyway, for this one, we are adding a restriction in this example, right? That a pizza must have a pizza base. Have a pizza base means have at least some pizza base. You cannot have a pizza without the base. Otherwise, I don't know how to eat, right? Okay. All right. So this one telling us that we can say has base. This is the property, okay, for the pizza class, such that it must be some pizza base. So when it is written, it will be like this, has base, some pizza base. So you will have two possible choice here, either some for the existential or only keyword for the universal. Take note that these are the syntax. So you cannot use your own word, right? It is the syntax for this class expression in ontology in Protege. Okay. Another example is to add some kind of pizza based on the name, right? As we already discussed, there are many types of pizza, such as many name pizza, such as margarita. You can create here some structure in a way that you first have pizza, Then add a subclass named pizza. Then under name pizza, of course, you can add many more of the name pizza in your restaurant. One here is margarita. And we want to say that for margarita pizza, it has some mozzarella and it has some tomato toppings. These are our initial definition of margarita. Okay. So to do that, you can create, right? Making margarita pizza and then state the restrictions. Has topping some mozzarella topping, has topping some tomato topping, and is under name class. So everything here is a subclass of, and these are connecting through and. Okay, so it means the condition of margarita is that it is subclass of name pizza and has topping some tomato topping and has topping some mozzarella topping. So this is one way to define class definition. And this is, yeah, okay. Then what's next? Oops. Then suppose we want to add a few more types of pizza. Call it American pizza and American hot pizza. In a way that for American pizza, we define it to be having these three types of topping, right? Mozzarella, pepperoni sausage, and tomato. While for the American hot, is similar plus this one, right? The pepper topping jalapeno. And that's it. You could also practice and do the same. So that's all about the quantifier restrictions that you can make use of, existential or universal, for the keywords some and only. And with this way, actually, you are defining the restrictions on properties of your class, restricting some properties. Okay, the next one is not on how many properties you can have and the values of the properties, but the next one talks about the specific value. For some class, you may want to define that instances of this class can only have certain specific values. For example, we may want to say that mozzarella cheese, okay, in which we use it for mozzarella topping, is originally from Italy. So we can say that here, can I adjust this a little bit? Okay. We can, okay, let's say we have an object property, namely has country origin. And we want to define that our pizza, our topping, or all these things, right, can have this property, has country of origin. So you need to properly define what is supposed to be the domain. And then we could say anything. Oops. So I would say for some simplicity, the domain is just the thing, okay? And the range could be country. right? For this has country of origin. Anything could have country of origin linking to the range class, which is country. Okay, so if we want to say that mozzarella topping class can only have this value, the property has country of origin with which link to the value Italy. That's it. This is to enforce some restriction that for mozzarella topping, the value can only be Italy. Okay. Then the next type, right, is cardinality restrictions. We learn cardinality in several other courses as well, such as object orientation, class diagram, such as database modeling, ER diagram, and so on, right? We, when we want to say cardinality restriction, actually, we are defining exact number that individual of a class must have this number, this exact number of properties. For example, if we have a class student, usually we want to define, right, that a class student enroll, for example, program or degree. We may want to define that the cardinality is minimum 1, maximum 1. That means one student, you can enroll for only one degree at some time, okay, for in one university at a particular time, something like that. Or you may have advisor, only one faculty, one advisor. So this also has cardinality 1 for the head advisor, right? Something like this. Okay. So you can define min and max cardinality for a particular property linking, defining a class, to define a class. So let's look at this example in the pizza domain. Suppose that we want to create something called interesting pizza. Our definition is that something interesting means it's rich of toppings. Okay, so in this definition in our restaurant, we want to say that interesting pizza has topping minimum 3. That's it. If your pizza has only 1 topping, it's not interesting. 2 toppings, no. 3, 4, 5, 6, 7, fine to be interesting pizza. That's it. That is our definition of interesting pizza here. Okay. And this is the way, right? Some sample screenshots of how to define it. And when we define it in the class definition, it would become that interesting pizza is equivalent to pizza and has topping minimum 3. Okay, this is some kind of theory, formal semantics and some theory of logic related theory. There are 2 things. When we are defining something in the logical related theory definition, there are so-called what is called necessary conditions. Another one is, if you want to go deep discussion, talk to Professor Du. Okay, about this stuff. Another is called necessary and sufficient conditions. Okay, what does it mean? Easy way to understand is to look at some example. Suppose that we have a class, name class in our ontology. You may define and imply that for this class, the necessary condition comprise these things. This condition 1, 2, 3, 4, 5, 6, 7, 5. These are the conditions define this class. Look at this arrow, it's just one way. Meaning that to be a pizza, for example, we should have topping. We should have this. We may have something else too. We define that what is so-called pizza class, and object inside pizza class will have this condition. So once you have something which is pizza, this is pizza class. Once you have some pizza object, oops. I cannot be too close. Pizza instance, okay, let's say, once you have some pizza instance, we can imply that our pizza instance will have this condition. Okay. Such as being I would say, let's say this is not actually a very good definition, but suppose, let's say, being a Thai citizen, Thai nation, I would have black hair, brown or black eyes, and this and that, right? So when you know someone is a Thai, you can imply without telling that how the person looks like, but you imagine, right, that, oh, that person who is a Thai should have black hair, black or brown eyes, and so on. These are necessary conditions. My example is not that good, right? It's not realistic as of now because there are so many Thai with the blonde and with this and that due to the mixture of the nations and so on. But anyway, but how about necessary and sufficient conditions? If you look at this, you see that the arrow defines bidirectional. Meaning also that if something you don't know whether it's a pizza or not, you don't know whether it's an object of that thing or not, that class or not, but it has this condition. So with this necessary sufficient condition, I was saying that if you have something, you don't know whether it belongs to that defined, we call it primitive class. Okay, that define primitive. Okay. Okay, now it will not work. So with the primitive way of defining, it is just one direction here, such as in this example, we are defining cheesy pizza to mean that the condition of cheesy pizza is that it is a pizza with at least one cheese topping, right? Otherwise, it's not cheesy. So if I give you, hey, here I serve you a cheesy pizza, you can imply, right? This direction, you can imply, I serve you cheesy pizza. You can imply that that cheesy pizza has at least one cheese topping for sure. Okay, this is just one way. But if I say that on the other way as well, if I have a pizza and also that pizza, one condition is that it is a pizza. Another condition is that it has cheese topping. Then I don't tell you that this is cheesy pizza. I tell you that, okay, here I give you a pizza with a cheese topping. Can you infer back that this is a cheesy pizza? If yes, this is the necessary and sufficient condition for something to be classified as cheesy pizza. Anything that satisfies these defined conditions can be implied to be in that category. For example, another example, I already said, right, that being Thai must have black hair and black eye. But suppose given someone with black hair and black eye, can you really say that this is a Thai? No, then it's not, it doesn't work on both ways for that example. It's just implying this condition one way, but not the other way around. Okay, so that is why for being a Thai, necessary conditions mean black hair and black eyes, but that those necessary conditions are not sufficient to infer the other way around. That's the meaning. Okay, so there are quite a number of things when you define anything to work both sides. Okay, if you notice, I did not say, but I will say now, that is, if you notice here, with the equivalent class expression, you are defining so-called defined class. That means you're giving necessary and sufficient condition of some defined class. You are defining a class based on a definition. However, if you are defining a class using only subclass of here, you are making just one direction, such as this one, we are defining mozzarella topping, such that it is cheese topping and it has original, has country of origin from Italy. Is this defined class? Shall we make it equivalent definition, defined definition? If you do this, if actually I move this definition to be defined class, meaning that we are making necessary and sufficient condition. What does it mean? It means anything that is a cheese topping and that cheese topping which has country of origin from Italy will become mozzarella. Is it true? No, there are some other cheese topping from Italy which is not mozzarella, right? But maybe, I don't know. I'm not cheese expert, but I'm sure that it's not the only thing, right? So they are not necessary and sufficient condition for you to infer them to be mozzarella topping. So it is like this, it is fine. This is already correct. Okay. And then let's move on. Any confusion? Let's practice more and more. I think this will be clearer and clearer. Think about being a Thai, being a Nepali, being something as I already mentioned, right? Having black hair, black eyes do not imply you to be a Thai, something like that. Okay, in my example. All right, the next part is to use a reasoner to make some inferencing of something that is not explicitly state, but it can infer more. Okay. For example, we already define interesting pizza to be what? To be a pizza and having minimum 3 toppings, right? 3 pizza toppings. Then if you start a reasoner, without starting a reasoner, it's just defining the definition, right? But after starting a reasoner, then you can see that there will be, I will skip this first, there will be more of the infer classes based on the definition you define. For example, you should have seen the interesting pizza here. Okay. Before we only define definition, later it will, this is from the infer tab. Okay, this is asserted. Asserted means what you define. Infer means it includes also inference results in addition from the asserted. So after running the reasoner, the reasoning engine will yield this additional infer result. For example, we could get that these are cheesy pizza because it contains cheese topping. These are interesting pizza, and so on. Okay, back to what I skipped. But before, no questions, right? Back to what I skipped. When you want to start a reasoner, need to make sure you already download, plug in this and that as required from the beginning, right? There are quite a number of reasoners you can use. And actually, what are different among all these reasoners you could use depend on the reasoning service you want to use. But what we will use basically are basic. So any kind of reasoner available will do the work. Don't worry. There is Hermit, there is Palette, there is this and that. They work with all the things you are going to do. Okay. So in our example here, we use Hermit. But as I said, if even you choose and try other, they will work as well. Once you click start and then you choose already which reasoner to start, then it will run the reasoning and you can change between asserted and infer. One of the noticeable difference is that with asserted, these will have white background. With infer, it will become yellow. This is to easily visualize spot the difference in terms of user interface. Mm-hmm. Yes. Yes. So that could mean that there's something wrong in terms of the way to assert the syntax or something is wrong. But I'm going to go a little further. And then if there are certain issues that doesn't work correctly, you can share the screen and we can discuss that what went wrong, what goes wrong. Okay. When you run your reasoner, and if you have this symbol, it clearly says that there's something wrong. That means there are some kind of inconsistency issue. That means you are conflicting the statements that you define. There are some conflicts in the statements that you define in your ontology. For example, what does it say here? Okay. For example, in this example, I'm not sure when you created your ontology, you may not have some inconsistency problem. That is good. But if there is inconsistency problem, the reasoner will not start and will not do anything, because when there are conflicting statements, it means that something is still wrong. Then the reasoning result, inferencing result will go wrong and it will not yield. So in this example, is the example saying that there is some, okay, this is yellow. So this is in the infer mode. And when there is something red, it alerts you to check that something is wrong there. Okay. And here in this, we are saying that there is some, we intentionally, in this example, intentionally define a class which is called probe inconsistent topping. That's very strange name, right? But it's just a name that we intentionally define it. Probe inconsistent topping. This one is defined to be a subclass of cheese topping and a subclass of vegetable topping. It is wrong and inconsistent because we used to define that these two class of cheese topping and vegetable topping, they must be disjoint. Then something that is a subclass of both is not possible. Such as you are having a class dog and a class cat, and you are saying that they are disjoint. You are defining one animal. Okay. And you say that this animal is a member, it's not a subclass, okay? But the same thing. This animal is a member of dog class, an instance, and also an instance of cat class. Will that become possible? This is really another example of inconsistency definition. This instance cannot be an object of dog class and an object of cat class at the same time because they both are disjoint. Or if it is not an instance, but you're defining a class X can also not become a subclass of dog and a subclass of cat at the same time. And this is the same example of probe inconsistent topping. And it will alert you inconsistency problem in your model. Okay. So this is what we already discussed. With reasoner, you can use for checking how good your ontology is. At least it should be free of inconsistency. That's the first thing. So reasoner can help checking that at least you are not contradicting yourself in terms of modeling the ontology, in which it could happen when your ontology becomes complex and big. You might mistakenly define something. Second, you can use reasoner to infer, right? Or discover implicit knowledge or information, such as we discussed before, infer something like the interesting pizza and cheesy pizza. We never say that which pizza is interesting. We never say which pizza is cheesy. We only define the definition through the equivalent class, right? Define class. Then you will obtain this automatically from the listener. Okay. And the same can be done. And when you try and something doesn't come out, it could mean that you start and stop the listener one more time, or click at synchronize, because when you start the listener and you do some change in your ontology model, if you make change, you may need to synchronize the listener one more time to make it rerun, something like that. Okay. And what else in this example? Vegetarian pizza. This is also defined. This can be defined. You can define here. We use class expression to define a definition of defined class. Okay, so this is necessary and sufficient condition for the class vegetarian pizza, saying that it is a pizza, right, that has topping only cheese topping or vegetable topping. Only means something beyond this are not possible, right? Because otherwise, then we cannot eat that pizza if we are vegetarian. We allow cheese topping or vegetable topping only. And actually, cheese topping is a super class, right? You can have mozzarella, parmesan, and many types of cheese topping. You can have vegetable topping, which is mushroom, olive, and so on, right? You are not making definite fixed class, but you are making the super class constraint on the super class of the topping, but inside there could be very many things. And your real pizza could be made of pineapple. Okay, Italian people will get angry if you say pizza has pineapple. And you cannot have also tomato sauce. You can have tomato, but not ketchup or tomato sauce, something like that. Anyway, that's just some side story. Okay, so once you define this vegetarian pizza, you can run a listener, and it should include or infer pizza that can be classified as vegetarian pizza. So how can we use this? Of course, as I refer back, we are running a pizza restaurant. So our customer may come and ask, right? Oh, I am a vegetarian. Do you have vegetarian pizza menu? Originally, maybe you'd never classify anything as vegetarian, but you can define the definition and let the listener find out for you. And this way is similar to several of the papers, case studies you have presented or read or listened. That is like the COVID one. We define that to be confirmed case, to be suspicious, to be this and to be that. It means that we need to have this and that condition. You are defining something like similar to sufficient and necessary condition, right? And then you are inferring that who belong to which class or category. Okay, that's the thing. We will talk about open world assumption, which means that when you are saying that margarita pizza has mozzarella and tomato topping, when you say that margarita pizza has tomato topping, mozzarella topping, This is what you say. It doesn't mean, and you cannot assume that it has nothing else. It may have, but you don't say or you don't model. Okay, it is like I say, I am a supervisor or advisor of Duke, but it doesn't mean that no other students that I'm also supervising, right? I only say just some small, some partial, something. It may include some other things too. So the same thing is that we cannot infer that Margarita is vegetarian because Margarita may have something else in which is a meat topping. It only says that it has these two toppings, but it doesn't say that it doesn't have something else too, right? So if we want to have Margarita classified as vegetarian pizza, you must say that Margarita, instead of saying that Margarita has some, remember we have topping. For Margarita has topping, some mozzarella topping, has topping, some tomato topping. That is what we said, right? It means that it has some of this, but it doesn't say that it doesn't have the other things. So you must change from some to only. If you want to say that Margarita only have tomato and mozzarella, then we can safely guarantee that Margarita is vegetarian pizza, right? Okay, that's the thing. So you could do that by trying to say only mozzarella or tomato topping. Okay, and I think that's the main thing. The rest is some additional stuff allowing you to do Sparkle query, writing Sparkle to execute your ontology. Okay, and return some results. And also, actually, there are GL query. The example, the paper that Siri shows, I think it makes use of the DL query, the screenshot, that one. Okay, we may have a look later on in more detail. Okay, but as of today, I think this is all important stuff that we should have discussed.